A critical security flaw in one of AI's most popular infrastructure tools just landed on CISA's exploited vulnerabilities list after 100 million Docker pulls. Plus, why vibe graphs might be AI's real trillion-dollar opportunity and the uncomfortable truth about AI in the legal profession. From the team at the Daily Brief, it's Saturday, April 4th, 2026. Good to have you with us.
We went through about 142 posts, articles, and threads across LinkedIn, Substack, and YouTube to find what actually matters today. Let's get into it.
So let's start with the big story. Okay, let's start with something that should make every engineering team sit up straight this morning. Rock Lambros flagged a story this week that's genuinely alarming. One of the most widely used connectors in the AI ecosystem. We're talking 100 million Docker pulls, the kind of tool that sits between your AI stack and basically everything else, just landed on CISA's known exploited vulnerabilities catalog. That's the list the federal government maintains of security holes that are actively being used by attackers in the wild. Not theoretically exploitable, actually exploited.
Yeah, and here's what makes this especially uncomfortable. Lambros also highlighted a companion piece of research called Agent RFC, described as the first paper to formally verify the security properties of a major AI SDK. This SDK has 97 million downloads. 97 million. And until this paper, nobody had done a formal security analysis. Let that sink in for a second. We've been building production AI systems on top of software that nobody had rigorously checked.
This is the pattern that keeps repeating in the AI infrastructure world. Adoption moves at light speed. Millions of pulls, billions of API calls, and security analysis comes later, if it comes at all. It's the move fast and break things ethos, except now what's breaking is the attack surface of critical systems. At the CISA summit at RSAC, Lambros noted that CXO panels are actively wrestling with this. How do you build trust in an AI-driven, cloud-first world when the foundational tools haven't been properly vetted? The honest answer right now is that most organizations are flying on faith. And CISA just told us that faith has a cost. Moving on. So everybody's talking about AI agents and chatbots and copilots, right? But data engineer and author Joe Reese is making a provocative argument that the real money, the genuinely transformative trillion-dollar opportunity, isn't in generating text or images. It's in what he's calling vibe graphs. And before you roll your eyes at another buzzword, hear this out, because the underlying idea is actually compelling.
Yeah, and here's the thing. Reese's argument goes something like this. The hard part of AI was never making a model that could write an email or summarize a document. The hard part is connecting AI to the messy, tangled web of real-world data relationships that actually drive business decisions. Think knowledge graphs, but built and maintained with AI assistance. Graphs that capture not just entities and relationships, but the context, the nuance, the vibe of how things actually relate to each other in an organization. He's essentially saying the plumbing is more valuable than the faucet.
This connects directly to another piece Reese wrote about where data engineering is heading in 2026. His consistent theme is that the data layer, the unglamorous work of modeling, connecting, and governing information, is where AI either succeeds or fails in practice. And he's been beating this drum in piece after piece. AI is here, but the hard parts haven't changed. The hard parts are data quality, data integration, data governance. The models are getting better every quarter. The data infrastructure underneath them, that's still a mess at most companies.
Right, and what makes Reese's framing useful is that it gives us a concrete way to think about where value actually accrues in the AI economy. It's not going to the teams that deploy the flashiest chatbot. It's going to the teams that build the connective tissue between AI and the real world. That's the vibe graph thesis in a nutshell. And honestly, it's more persuasive than most of what I hear from the agent hype crowd.
Here's something that caught my eye. Here's one that cuts against a narrative we've all heard 100 times. AI is going to democratize legal services, make lawyers cheaper, bring justice to the masses. The team over at Normal Tech, the folks behind the AI Snake Oil book, which just became available for pre-order, published a sharp analysis arguing that AI won't automatically make legal services cheaper. And their reasoning is worth unpacking because it applies way beyond law.
The core argument is about market structure, not technology. Even if AI makes individual legal tasks faster or cheaper to perform, the savings don't necessarily flow to clients. Law firms have enormous incentives to capture those efficiency gains as profit rather than pass them along as lower prices. The legal market isn't like buying airline tickets where transparent pricing and competition drive costs down. It's opaque, relationship-driven, and dominated by information asymmetry. Your lawyer knows what the work is worth to you, and they price accordingly.
This is a version of a broader pattern that Import AI's Jack Clark has been tracking in his coverage of winners and losers in the AI economy. Clark wrote about how AI systems tend to absorb human power rather than distribute it. The efficiency gains from automation often consolidate in the hands of whoever controls the system, not the end users. In law, that's the firms and the platforms, not the clients.
Right, and what's interesting is, the Normal Tech team also published a fascinating piece asking whether AI can automate computational reproducibility. Basically, can AI help scientists verify each other's work? Their answer is nuanced. AI can help, but the fundamental challenges are institutional, not technical. There's a pattern here. The technology works. The bottleneck is human systems, incentive structures, and power dynamics. Anyone telling you AI automatically makes things cheaper or fairer is selling you something.
Now, shifting gears a bit. If you build or evaluate large language models for a living, Sebastian Rashka just published 2 pieces that deserve your weekend reading time. The first is a comprehensive comparison of major LLM architectures. And we're not talking surface-level transformers good, RNN's old stuff. Rashka goes deep on the actual design decisions that differentiate models, attention mechanisms, positional encoding schemes, normalization strategies, the trade-offs between mixture of experts and dense architectures.
What makes this valuable isn't just the technical depth, it's the framing. Rashka's argument is essentially that we're past the era where one architecture dominates everything. The frontier is now about matching architecture to use case. A model optimized for long context reasoning looks fundamentally different from one optimized for fast inference on edge devices. And as the field matures, those architectural choices matter more, not less, because the easy gains from scaling are getting harder to come by.
His second piece, Reasoning from Scratch, takes a first principles approach to how models actually reason, or fail to reason. This connects to one of the more provocative findings in Import AI's recent coverage, the idea that LLMs are now training other LLMs. Jack Clark covered a 72 billion parameter distributed training run where models essentially taught each other, and the implications for architecture design are significant. If your training pipeline includes synthetic data generated by other models, the architectural choices that matter shift. You need to think differently about what signals the model is learning from and how to prevent mode collapse.
Right, and what's interesting is, Import AI also flagged that computer vision remains harder than generative text, which is a useful corrective to the narrative that AI is just getting better at everything uniformly. It's not. Some modalities are fundamentally more challenging, and architecture choice is a big part of why. Rashka's work gives practitioners the vocabulary and framework to reason about these trade-offs concretely.
There's another angle worth talking about. Let's zoom out to the big picture for a moment, because Import AI's Jack Clark has been on an absolute tear covering the geopolitical dimensions of artificial intelligence. And his latest issue, number 451, introduces a concept that stopped me cold: political superintelligence. not superintelligence. In the paperclip maximizer destroys the world's sense. Superintelligence as a political phenomenon. AI systems that are so capable at persuasion, information synthesis, and strategic reasoning that they fundamentally change the balance of power between institutions and individuals.
Clark has been building toward this idea across multiple issues. Issue 450 covered China's development of an electronic warfare model, and something he called a scaling law for cyberattacks. The idea that as AI capabilities improve linearly, the attack surface grows exponentially. Issue 446 explored nuclear-capable nations racing to integrate LLMs into their defense systems. And Issue 445 tried to put timelines on superintelligence itself, alongside breakthroughs in AI-driven math proofs.
What ties all of this together is Clark's consistent argument that AI governance is falling catastrophically behind AI capability. He covered the idea of AI regulating AI and the Red Queen dynamic, where regulators and developers are locked in an endless race, each forcing the other to escalate. He's even discussed the extreme scenario, preventative strikes to take down AGI projects. That's not science fiction anymore. That's being discussed in policy circles.
Right, and what's interesting is Google's Society of Minds approach, also covered in Issue 451, is relevant here too. The idea of multiple AI agents collaborating, specializing, and negotiating with each other has obvious implications for both capability and control. If a single model is hard to govern, what happens when it's a society of models? This is the conversation the industry needs to be having, and Clark is one of the few writers treating it with the seriousness it deserves.
One more thing before we wrap the main stories. Let's close with something that hits close to home for a lot of our listeners. Joe Reese has been writing honestly, sometimes brutally honestly, about the state of the tech job market and the human side of this AI transition. His piece, "The Job Market Isn't Dead, but Seems Far Pickier These Days," captures something a lot of people are feeling but few are saying out loud. The jobs are there, but the bar has shifted dramatically. Companies want people who can work with AI, understand data infrastructure, and ship, not just people who can pass a leak code interview.
Reese's companion piece, Dawn of the Brain-Rotted Zombies, is even more provocative. He's arguing that the constant fire hose of AI hype, hot takes, and dopamine-driven content consumption is producing a generation of professionals who know buzzwords but can't build anything. They can talk about RAG and fine-tuning and agents at a dinner party, but put them in front of a real system and they freeze. It's a harsh take, but it resonates with hiring managers I talk to.
His Lessons I Had to Learn the Hard Way series drives this home with personal specifics. And his piece on the insanity of data education makes the structural argument. Our educational institutions aren't preparing people for the work that actually needs to be done. They're teaching yesterday's tools with yesterday's assumptions. Meanwhile, the work is changing faster than curricula can keep up.
Right, and what's interesting is, Abdirahman Jama's viral LinkedIn post about 6 system design rules every backend engineer must know. Starting with pick postgres unless you have a specific reason not to, is the perfect complement to Reese's argument. The fundamentals haven't changed. Databases, system design, understanding trade-offs, that's the foundation. And the people who have those foundations are the ones thriving in this market. The ones who skip the fundamentals to chase the hype cycle, they're the ones struggling.
All right, let's zoom out and talk about the bigger picture. What are the main themes running through everything we covered today? The first big theme is security debt is compounding faster than AI adoption. The gap between deployment velocity and security verification is creating systemic risk that CISA alerts reveal but cannot close on their own.
Next, infrastructure over interfaces. Across data, law, and enterprise AI, the consistent signal is that whoever controls the connective layer between models and reality captures the value, not whoever builds the prettiest front end.
Next, governance as a geopolitical race condition. The international competition to deploy AI in defense and cyber warfare is outpacing any coordinated governance effort, creating a stability risk that no single nation can solve unilaterally.
And the last one, the fundamentals premium. As AI automates surface-level tasks, the market premium on deep technical foundations, system design, data modeling, architectural reasoning, is increasing, not decreasing. So if you're going to take away a few things from today's episode, here's what I'd remember.
Number one, if your AI infrastructure tool has 100 million downloads and zero formal security audits, the question isn't whether it'll be exploited, it's whether it already has been.
Number two, the companies that win the AI era won't be the ones with the best models. They'll be the ones with the best data plumbing connecting those models to reality.
Number three, AI efficiency gains flow to whoever controls a system, not whoever uses it. If you want cheaper lawyers or cheaper anything, you need market reform, not just better tech.
And finally, in a job market reshaped by AI, the people thriving are the ones who learn Postgres before they learn prompt engineering.
That's the Daily Brief for today. All the sources and links are on the website if you want to dig deeper.
Thanks for listening. See you tomorrow.